All right, friends, it's your boy, Mr. Shady, coming at you with Unit 3, Lesson 4, Scaled Relationships. In this lesson, we're going to explore what we've talked about scaled copies across the last couple of days. The first thing says 3 quadrilaterals, part 1. It says each of these polygons is a scaled copy of the others. And so it says, name 2 pairs of corresponding angles. What can you say about the size of these angles? So I know that angle D, corresponds with angle H. So angle D and angle H are corresponding angles. And from that, like we talked about, if they're corresponding, that means and they're scaled copy, that means that their angle measurements must be the same. So angle D and angle H have the same angle measurement. We've talked about that in a previous lesson where we explored it with tracing paper. So they should have the same angle measurement. Another pair of angles that correspond is angle C and angle G. And they should also have the same angle measurement. And so what we talked about is that if we know that something is a scaled copy, then their angles should be exactly the same from one copy to another. So we've explored that through tracing paper in class, and so now we're looking at it from this standpoint. So I named those things, and so now this too says check your prediction by measuring at least one pair of corresponding angles. So I can measure any pair of corresponding angles. So this is a protractor, my friends, right? And so in order to use a protractor, what we're gonna do is you have a little dot here, right? Some people might not have used this before. So you have this little circle here. What you're gonna do is you're gonna put that on the angle that we're looking at. So we're gonna look at angle H, and we're gonna look at angle D. So right here, I'm gonna put that on angle H. Now notice that what I need to do next is I need to move this lines, the 0 thing here. So and I need to keep that centered on that so that I can measure the angle. So this angle is opening up this way. And so notice that it basically is gonna continue and hit that about 125. So H's measurement is about 125 degrees. It does say round to the nearest 5. And so what we have there is that. Angle D, right? So if I do the same thing for angle D, I want to make sure that this is about, the same, or it should be the same measurement. So that looks to be about 125 as well. So what we talked about is that these angle measurements are the same. So we just used our protractor to find that out, and it turns out that they are the same measurement. So record your measurement to the nearest 5. So angle D equals 125 degrees, and angle H also equals 125 degrees. And because those have the same measurement, it's a scaled copy, we need to understand that angle measures in a scaled copy are equivalent. And so that's the big takeaway here, is that angle measures in a scaled copy are equivalent. It doesn't matter if one is small, one of these figures is smaller than another, it should equal the same thing. So that's 4 1/10, 3 quadrilaterals, part 1. Here is the same thing. Now it says each of these polygons is a scaled copy of the others. You just saw these in the previous one. You already checked their corresponding angles. So this one says the side lengths of the polygon are hard to tell from the grid, but there are other corresponding distances that are easier to compare. Identify the distances in the other 2 polygons that correspond to DB. So DB is a distance from this point to that point. Notice that that's a total of 4, right? And so an AC, so we want to be able to, which ones correspond to that, and AC, which is straight across from each other. So for DB, right, in this one is HF, so HF, and so we have 1, 2, 3, 4, 5, 6. That equals 6. And for AC, and then for the next one, we have LJ is 1, 2. That looks like LJ equals 2. And then for AC, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So GE equal, or I guess it's not GE, I'd write that backwards. EG is 9, and then IK is, looks like 1, 2. IK is 2. So those are the corresponding different distances there. Let me check that real quick. So that's 1, 2, 3. No, that's 3. My bad. So that is 3 there. So I need to look really close at that. This one should be 2. That should be 3. And so look at the values in the table. What do you notice? So the corresponding distances are related by the same scale factor even though they are not side lengths. So corresponding distances are affected by the same scale factor even though they are not side lengths. Right? So, and what that means is if this is 4, right? This is 4 and that's 6. So from 4 to 6, we have 6 over 4, and then we have 9 over 6. If I simplify those, this gives me divide by 2 here, this gives me 3 halves. Divide by 3 here, this gives me 3 halves. So those are basically what we're trying to get at, is that the corresponding distances are affected by the same scale factor, even though they're not side lengths. So corresponding distances are affected by the same scale factor, even though they are not side lengths. So that's the main point. We're supposed to get away from that, get out of that. And so supposed to measure those and see that. So I'm going to move on to the next little activity here. So number 3 says the larger figure is a scaled copy of the smaller figure. So we're going from this to that, right? And so if AE is 4 unit equals 4, that means from here to there, they're saying is 4. How long is a corresponding distance? So they're asking how long is it from H to L? Well, we know a couple things here. We know to go from my scale, I need to do copy over original. And this one is my copy, this is my original. So what we're gonna do, how we're gonna find our scale factor that they're using here, is we're going to write a ratio. We're going to put 15 over 6. Because the copy side that we know is 15 and the original side is 6. So then, given this ratio, I'm going to reduce, right? Reduce based off of, can I simplify this fraction? And so what I'm going to do is I'm going to divide both of these by 3. This gives me 5 over 2. So my scale factor seems to be 5 over 2. And so what I'm going to do now is I'm going to take 4 and I'm going to multiply that by 5 over 2. So remember, this is, we need to put a 1 underneath here. So then I have, this is 20 over 2. 20 divided by 2 is 10. So basically HL is side length is 10, since this is a scaled copy. So now it says if IK is 5. Now it's saying that this distance is 5. How long is the corresponding distance in the first figure? So we're talking about BD. Well, if the scale factor going from this to this is 5 over 2, then the scale factor going backwards would be the reciprocal. So we're going to flip this, say this should be the reciprocal. So this should be 2 over 5. So we're going to take our measurement, which is 5. And then so we're going to say 5 times 2 is 10, divide by 5, that equals 2. So this side length side length for B, D should equal 2, right? And that's how we find that. So the connection there is we write it as a ratio first, we simplify our ratio, we apply our ratio to a side length given, we find our answer. Then when it is asking us to go backwards, we do the reciprocal, because those are reciprocals of each other, so it's a scaling down, and then that tells us how to go backwards. So I apologize if that's a little wordy there, but basically we're going from this to that, which is a scale factor of greater than 1, and then when we go backwards is a scale factor less than 1, which is that 2/5 there. And so that's what we're trying to get at tomorrow. 4 3/10 says scaled or not scaled. So it says here are 2 quadrilaterals. And it says Lola says that polygon ZSCH is a scaled copy of polygon XJYN, but Andrew Roberts disagrees. Do you agree with either of them? Explain or show your reasoning. And so what we're going to do is, remember in the second activity, we measured corresponding distances that were, you know, across from each other. So I'm going to measure here like this. So this is 1, 2, 3, 4, 5, 6. That's 6 units across, right? And then on Z to C, it's 1, 2, 3, 4. That's 4 units across. And so this is your original. And then this is your copy, right? And then I'm going to measure the distance from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That looks like it's 9. And then this one over here is 1, 2, 3, 4, 5, 6, 9, and then that's 6. So what we're going to do is we're going to write our copy over our original. And we're going to do that twice here. And we're going to see if these are equivalent. If they are equivalent, then that means that we might have a scale copy. If not, then that means that we might be in trouble. And so we'll have to look at a couple things here to determine that. So in our copy, right, so copy is 4, and then this is 6, and then this is 6 out of 9. So it looks like this reduces to 2/3, and then this reduces to 2/3 as well. So the sides work out. So we can't just, so in this problem we could say, yes, it does look like it's a scaled copy, but we need to make sure that we check our angles. So looking a little bit closer at this, I'm going to get my handy dandy protractor out, and I'm going to see if X and Z have the same angle measurement. So I want to make sure that I check if X and Z have the same angle measurement. So remember, to use this, you need to line it up, you know, with it. So like that. And then that looks like that is about 105. And this corresponds with Z over here. So I'm going to move this and that. And that is actually a sharper angle there. So that would be throwing you off. That looks like it's about 125. So their angle measurements are not the same. Thus, Andrew is correct. Andrew Roberts is correct because they are corresponding angles are not equal. Okay? Record the corresponding distances in the table. What do you notice? So I've already done that work for you. X to Y is 6. J to N is 9. Z to C is 4. And S to H is 6. And so what I notice is that the sides have the same scale factor. So measure at least 3 pairs of corresponding angles in that using a protractor, record your measurements to the nearest 5. So I measured 1, and it wants me to measure some more in this, so I'm gonna measure angle X. So now I'm gonna measure angle J. To the nearest 5, 5th, right? To the nearest 5. That angle goes up like that. That looks like it's 45 degrees. Angle J, or could be 40 degrees. So angle J. So angle J equals 40 degrees. And then the corresponding one for that would be S. And so for S, that looks like it's about 40 degrees as well. It's a little off there. It's about 40 degrees, so angle S equals 40. So what I've noticed so far is that those angles are measured equally, but the first angle I looked at in examining this, I've noticed that those two are not the same measurement. And so what I noticed is that angle measurements are not the same. Thus, they are not scale copies. Okay, so we're moving on to the next part. So the next part says, do these results change your answer to the first question? So do these results change your answer? So since the corresponding angles are not equal, the polygons are definitely not scaled copies. So angles are not equivalent. Thus, they are not scaled copies. Right? So I knew what to check, but if you didn't know to check the angles, then it's okay, because we should get to the end of that. Here are two quadrilaterals. It says, Covey says that polygon EFGH is a scaled copy of ABC, but Laura disagrees. Do you agree with either of them? Explain or show your reasoning. So it looks like the corresponding angles seem to be the same size, right? And then if I look here, that looks like it's scaling, so the side lengths, comparing the side lengths, that looks like it's being reduced by 2. So then I say, okay, so 2 divided by 2 equals 1, but does 4 divided by 2 equal 3? That is not true. So thus Laura is correct, because the distances are not multiplied by the same number. Okay, so we found out that 4 divided by 2 does not equal 3, and so we want to show that there. 2 divided by 2 does equal 1, but then when we apply that, it does not equal 3, and so we get our final answer. So then I'm going to look at our last activity tomorrow, which is called comparing pictures of birds. Here are 2 pictures of a bird. Find evidence that one picture is not a scale copy of the other. Be prepared to explain your reasoning. Well, from our first definition of scaled copies, we talked about distorting an image. So I know that that's distorted, right? And so you could probably say that that's how they're not scaled copies. But if I ask you to find me evidence, you can measure anything on this bird. So what I'm going to do is I'm going to try to measure the wing span. So I'm going to start at 0 here using my protractor. I'm going to try to measure this wing, right? So that's about 2 4/10. Let's say that. And that this distance is, on this bird, for for the wing itself is about 1.5. And then measure another distance on this bird. So the tip of this wing to there, say that's 3, right? That's 3, and then this one here, that seems to be the tip to there, reads about, let's say 6. So this one is double, right? Like that's double of each other, but 2.4, so 1.5 times 2 does equal 3. But if I apply that, so 3 times 2, if I look at it that way, 3 times 2 does give me 6, but 1.5 times 2 does not equal 2 4/10. So they are not scaled copies. And so basically, this is an application question of what can you do to make proof that this is distorted. So you're trying to find your proof in that pudding. So this is tomorrow's lesson. I hope that you enjoyed this video. I look forward to talking to you about this tomorrow. I find that there's a lot of cool stuff in here to help us develop our understanding of scaled copies. See you then.